perspective really changed your look at what physicists do?
Well, you see, I've developed a theory along these lines, which I call the enfolded order, or the implicate order. I don't know if you want to go into that now.
Well, let's have a try.
The ordinary idea of matter is it's an object which exists external to other objects, you know, and passes through space continuously, and goes from here to there, right, and connects up with other objects, and makes the whole that way. Now, I want to propose, just to give the idea of what I mean, I saw once on BBC television a device which I realized would be very useful for my purposes. It was made at the Royal Institution in London, and it consisted of two glass cylinders, concentric, one inside the other. The inner one was held fixed, and the outer one turned slowly, and you placed a very viscous fluid, such as glycerine, in between the two cylinders. Now, as you turn the outer cylinder, the glycerine on the outside is turning, the glycerine on the inside is fixed, and in between it's moving intermediate rate. So if you took a small bit of glycerine, it would slowly get drawn out into a thread. Is that clear?
No, you've got glycerin in your tube,
and
in your cylinder,
between the two
right?
cylinders.
And then you put a drop of...
The next stage is to put a drop of insoluble ink, which consists of particles of carbon, for example.
So you can see this drop suspended in the glycerin.
Suspended there. And each particle of carbon is now carried along by the glycerin, you know, at the speed of the glycerin. And since the outer parts of the glycerin move faster, the particles of carbon are carried apart. Eventually, they become so fine as to be invisible, right? Now, you then turn this machine around slowly, and the particles retrace their paths, and suddenly it forms a droplet again of glycerin, right? And that actually happens. I saw this happening the first time there when it was shown on the program. And we actually have, and now, I propose now that this droplet has been folded into the glycerin, right? And it is then unfolded. And now, I want to say that that sort of process helps to explain the behavior of particles. That is, it's only an analogy. We mustn't take it too literally. But for example, suppose I put two droplets in, one next to the other, near the other, and I fold it up. Now, the particles from one droplet are going to sort of mix with the particles of the other, so they're indistinguishable. Yet if we turn the machine around, each particle seems to know where it must go, and it goes backward to help form its own droplet again, right?
Right.
So...
Now, what does that illustrate?
Well, that illustrates a new order, because we say, see, if we put in a number of droplets in a row, you see you have what's called an order, right? And we could fold them all up. The order seems to be absent, but it's still present, because when you unfold it, it'll all come right out again. So I say there's a non-manifest order. There's an implicate enfolded order, right?
Okay.
And I said that notion of order is a different notion of order from the one which science has been using, which is the unfolded or explicate order, in which we say only things outside each other count, and only external relationships of things outside each other are to be part of the fundamental laws of physics.
Well, a scientist would look at what was in the cylinder at any given moment and then try to describe the relationships of the various streams of...
That's the way you would analyze it, but that's why I say it's only an analogy. But I say that that movement abstracted from this analogy is what I want to use. I say quantum mechanics has this process of unfoldment without being able to reduce it to the bits of glycerin and carbon. Is that clear?
Okay.
So the bits of glycerin and carbon are only an illustration of something which I want to call attention to, which is different, right? Is that clear?
Yes.
Now, therefore, what I'm saying is that the fundamental properties of matter are moving in this order of unfoldment. And I give you an idea that suppose we go back to that analogy, and I put in a particle and turn it a certain number of times. I call it n times. I put a particle in a slightly different position and turn it n more times. The first one is 2n. We go on, the third is n, 2n, 3n. We put in a large number, and we now turn it backward fairly rapidly. One droplet after another emerges, and it looks as if a particle is continuously crossing the space.
Right.
Now, I say that's the image that I want to give as to what a particle really is in quantum mechanics, that sort of movement. And therefore, the particle is present in the whole and is merely unfolding and manifesting as a separate thing, but its actual existence is not separate. It is an abstraction. That droplet, that separate droplet, is an abstraction due to our perception, right?